In this video, we are going to be using some of the commands that come after a regression. In the last video, we learned basic regressions, with some options, so a robust standard error option, and then also without a constant. In this video, we're going to be using, after we run a regression, we can use Stata to list some of the numbers that were displayed in that regression. That were housed in there, and we can recover them, and those are handy sometimes as maybe we want to test two different regressions over another. So first thing that we're going to do is I'm going to bring in the college distance data that we used in the last one, and then I'm just going to run a basic regression. So we'll just regress education. We'll go with tuition, urban, mom college, income, own home, female, dad college, by test. And if we look overall with this regression, r squared is 0.13 or 0.32 ish, so we're explaining about 32% of the variance in this case. Over here we see it based on our p-values that most of our variables are significant. This one's tuition significant at the 10% range. As tuition goes up, education decreases, college becomes more expensive. All the rest are significant at the 5% level, except own home, which is insignificant. So it does not matter if the family owns its own home or not. One reason that we may say this is it's probably going to be highly collinear with high income. So high income is likely to be 1 if own home is 1, and both of them are both likely to be 0 if one of them is 0. So we just ran this basic regression, and now let's suppose that we want to recover some variables. Well, to see what Stata has, we can just go help reg. So we type in help, and we get this little help menu, and then we can see regress, the dependent variable, the independent variables. We can do if, so I'll show you one of those in a little bit. And then we have no constant, VCE robust. We can report confidence levels, so forth. The default is 95%. And then if we scroll down to the bottom, what we see is here's the stored results from the regression. So they store it using the E command, and then we have all of this stuff. So EN would be the number of observations. ERSS is the residual sum of squares. ER2 is the r squared. So we can recover all of those. Since these are scalars, if we want to list a scalar, we just use the display command. So we say display ER2. You got to spell display correctly. And so here's our r squared of the regression we just ran. So 0.317973922, which is what we got right there. So we can always recover what we just did, and we can house those or save these if we want to. So I could save that as a scalar, and I could recover that information later if I needed to. If I run another regression, this ER2 is replaced by the regression I have just ran. If I want to list the coefficient vector, which in this case it's a matrix, so I'm going to have to use the matrix list command. So I use matrix list, and then I type in EB, so B being the coefficient of betas, which is our coefficient estimates, our matrix of betas. And so it comes up and it shows me my coefficient on tuition is minus 0.366, which is exactly what we see right there. And we have our constant, which is 8.84, which is right there. So we can see all of our coefficients as well. So we can use that and save those if we want to compare at a later date. One last thing that we want to do is regress regress if only we're in a certain bin. So we can use the if command in a regression as well. So maybe we want to understand, do males and females have different education or variables that are significant in determining their education. So maybe females are more responsive to tuition rates than males, or they're more responsive to their test score than males. Males might be more influenced by the state hourly wage in manufacturing in 1980. That would be a fairly male-dominated job, so females may not respond to that variable, but males do. So we can run the regression. So we can just go regress education, and we'll do the manufacturing rate, mom college, dad college, and test score. And we're going to regress that if female equals 0. So in this case, we're running the regression for males. And this is what we get. And then I can just go ahead and I can do this regression one more time. And this is what we get for females. Okay, so overall, if we're comparing the results, they appear to be very similar, especially the by test. So males and females appear to respond about exactly identical to their standardized test in college or in high school. Females are more responsive to whether or not their father went to college and whether their mother went to college. And manufacturing rate is insignificant, and it's insignificant up above as well. In fact, males don't, we can't significantly say at a 95% level that males respond to whether or not their mother went to college in this regression. So we could do this. Another command that we could do is just the by. So we could do by female, comma, sort, reg, ed, the state, wage, and manufacturing in 1980, mom call, dad call, and by test. And I forgot a colon after sort. And here's what we get again. So here's the same regression results we just did, but it does it all housed in one command instead of two separate commands. And obviously here we can see that 484 of our observations are male, 566 are female. So these are just some of the things that we can do with a regular regression. So you can always use if or by, and then we can always recover some of the estimates. So if I just go display r squared, I ran 2 r squareds here, but if I display, this is 0.2963, that's for the last regression stored. So we can always recover those. If I wanted to save both, I would have to save it after each regression, and I could use that doing the scalar command. So I could go scalar r2 equals e r2, and now I have r2 stored as a scalar, so I can run my male example, and if I go display er2, this is what I get. If I display my r2, which I saved from my last one, it should equal 0.296, and that's what I get. So now I have this saved in my memory, while the r squared from the regression I just ran isn't going to be saved. It's always going to be overridden by the newest regression that we've run instead of.